Hi everyone, in this demo we present our tool that automatically detects for likely design flaws in entire object-oriented architecture. Entire architecture is a recommended industry practice as it promotes separations of various concerns into layers. One commonly used in entire architecture is the separation of class into three stereotypes, namely boundary, controller, and entity. Class stereotypes are not just symbols, they come with design rules governing their behaviors and responsibilities. In the natures of a class is not apparent to developers or its behavior do not match its stereotype level, developers are prone to make mistakes, violating the rules, especially as the code evolves over time. There are two common variants of such rules, namely robustness rules and well-formed rules. Unfortunately, many software projects during development or maintenance have little documentations. Many design documents, including those specifying stereotype levels of the classes in a program, are often missing. We implemented our proposed system as an Eclipse plugin and tested our tools on a number of students' projects and real software systems. Our violation detection framework to infer class stereotypes are shown as follows. It has two phases, namely training and testing phases. In the training phase, we build a statistical model using a machine learning technique that can discriminate the class stereotype based on a set class with given stereotypes. In the testing phase, given a class or a program containing more than one class with no stereotype labels, we predict the corresponding stereotype for each class based on the models. And there are 5 different processes in the framework. First is the extractions of basic framework and features constructions, which appearing in the training phase and the testing phase. Then there are a model learning process, which combine a classifier from the training and the features constructions during the testings. Then follows stereotype assignment, and lastly the violations detections. We implemented our solution as an Eclipse plugin. The plugin consists of an additional button in the Eclipse toolbar. This button, there are multiple options presented to the users. One is the training the models, and the other one is checking for design flaws, either robustness or well-formed rules. Now we would like to train a model. Once the user starts the training phase, a dialog box will appear to ask users for the jar files as well the class label. Once you're ready, just click the train button. Once our system is trained, it could be used to detect for likely violations of well-known design rules. First, you need to choose the project. Then, click the button and choose the options that you would like to check. In this case, we choose the robustness. Internally, our systems will compute likely stereotypes of the individual classes based on internal trained models. The stereotypes in turn would be used to detect the violations that would then reported to the users in the additional tabs in the bottom of the Eclipse IDE. User could then click any of the reported violations, and which will bring users to the code containing the design violations. As a summary, our tools works on entire architecture with well-defined notations of class stereotypes. It gives labels to the remaining non-analytic class. Likely design flaws are later detected by finding violations of well-known design rules. Our system has been implemented as an Eclipse plugin. Primarily experiment results on several small and medium-scale systems have been promising.